All right. This is the review for 2.4, the quiz entirely on proofs. Let's go through the answers. Number 1 here, we're going from adjacent to straight to saying supplementary. So reason 1 would be if two adjacent angles form a straight angle, then supplementary. Reason 2, we went from this given right here to say that we're supplementary, so this is definition of supplementary. Actually adds equal 180. Number 3, we took these three. This is not substitution. This is supplements of congruent angles are congruent. So we got subs of congruent angles are congruent. 4, we went from congruent to equal, so that's definition of congruent. 5, we went from the bisector, which was given, to 3 and 4, so we got definition of, look for it, it's angles, so angle bisector. 6, congruent to equals again, so that's definition of congruent. And then number 7, you're taking these two statements and we're actually subtracting from them, so this is our subtraction property, subtraction. All right, those are the first 7. Let's move on. The next one, we're at number 8. So 8, we're going from the comp to saying they add equal 90. So this is definition of complementary. Number 9, we see interior to go from there. So that's angle addition. 10, we're bracketing them together. That looks like we're substituting. So substitution. 11, we said something was 90, so it's at a right angle, so that's definition of right angle. 12, we went from perpendicular to right angle, so definition of perpendicular. And then 13, hey, one right angle, two right angles, so we know that all right angles are congruent. Hopefully you're doing well so far. If not, you should be using your flashcards to look at while trying to figure out what the reasons are. Moving on, number 14 here, we went from bisector. What are we bisecting? Segment, so it's definition of segment bisector. 15, we went from congruent to equal, so definition of congruent. 16, you see the word between, so it's definition of betweenness. 17, we are taking this and plugging it in here, so we're using substitution. 18, you see the word midpoint to go from there, so that's definition of midpoint. 19, congruent to equals, so 19, we got definition of congruent again. 20 is over here. 20 is a tricky one. We haven't done 20 yet, so we're getting rid of the 2 on each side. So that is actually division. And you won't have to do that on the quiz. And then 21 is definition of congruent again. Yeah, we'll learn division in 2.6 when we do it. All right. Now to write your own proofs. Okay, I give you 4 types of proofs. You have to be able to understand all 4 because you'll be writing 3 out of the 4 yourself. So example 22 here, they give you 2 givens that are numbers. So you obviously need to plug them in somewhere. Okay, to being able to plug them in, you need to create the angle. And to create the angle, you need to use angle addition. And where does angle addition come from? Angle addition comes from that interior idea. So for number 22, you have to start out with that idea of interior. So D is the interior of angle ABC. Underline it because you know you can assume it, so it's given. Angle, reason 1, angle 3 plus angle 5 equals angle ABC. Now this is where you want to plug the numbers in. So then underneath that you got angle 3 equals 49, angle 5 equals 41. Both of these together, now we can say angle ABC equals 90. and then if something equals 90, you can call it a right angle. And if something is a right angle, you know what we wanted to end with, that they are perpendicular. So ray AB is perpendicular to BC. Reasons: 1, you have angle addition because you went from the interior. 2, you did substitution. 3, definition of right angle. And 4, definition of perpendicular. So if you see one of these on your test where you have numbers for certain things, you know you're using angle addition, and you're going to have to use the substitution idea right after. So that's your idea. That's what you have to do for that question. Okay, let's go over to number 23 and look at it. What do we have? FG is perpendicular to BF. So FG perpendicular to BF, so that gives us a right angle here. So this gives us a right angle. We'll make a little note at GFB. We have a right angle already here. And then we know 1 is congruent to 4. Well, we learned in 2.4 that, hey, guess what? If this is perpendicular, or if this right angle and these are adjacent, they're complementary. If this is a right angle and these are adjacent, this is complementary. And these are congruent, so then the leftover pieces have to be congruent like we want. So that's what we need to do for this next example. I'm going to switch colors so you know which one matches with this. So I'm using red for this example. So we'll start with the perpendicular. So we got FG is perpendicular to BF. Underline it because it's given. Reason 1, we got angle GFB is a right angle. We needed complementary, so that makes angles 4 and 3 are adjacent. Underline it, bracket it together. Reason 2, angles 4 and angles 3 are complementary. There's the first piece. Second piece, we are given that angle ABF is a right angle. Given. We know that 1 and 2 are adjacent, which are forming angle ABF. These two together, same reason as here. Angles 2 and angles 1 are comp. And then we knew from the given angle 1 and angle 4 were congruent. These three together, up to reason 3, angle 2 is congruent to angle 3. Reason 1, we have definition of perpendicular. Reason 2, we have if two adjacent angles form right angle, then comp. And 3, we got complements of congruent angles are congruent. And we're done with the second proof. So there's going to be one on the complement and supplement idea that you will have to do on your own. So hopefully that is better understanding for you. Okay, so let's move on. F is the midpoint of BG. So F is the midpoint of BG, causing these two to be congruent. So if you need to give yourself a note that that's what's going to become congruent from that piece. The next piece bisects. So these two pieces are congruent. So we got GE congruent to EC. And then we know that FG is congruent to GE, so that's a double marker. So this needs to be a double marker, which then makes this a double marker. So that means all 4 pieces are congruent. So then we can say BF is congruent to EC by substituting them in and rearranging them. So what is that proof going to look like? Well, we'll start with F is the midpoint of BG. All right, underline it. That gives us reason 1, BF is congruent to FG. Second one, we got FE bisects angle GC. Different reason than above, so we got reason 2, GE is congruent to EC. And then last but not least, we have FG congruent to GE, given. Well, we can't substitute them in yet until they equal each other. So we're up to reason 3. We can say BF equals FG. Same thing goes here, same reason. We can say GE equals EC. And same reason, we can say FG equals GE. Now that they're all equal, they could bracket together, substitute in, and pick the ones we want. BF equals EC. Ran out of room, so I'll come down here. Reason 5, I can now say BF is congruent to EC, and I'm done with my proof. What are the reasons? Well, reason 1, we got, see the word midpoint, so definition of midpoint. Reason 2 is a bisector, so it's definition of, and then we look at it, see segment, so it's segment bisector. All right. Reason 3, we got definition of congruent, because we went from congruent to equals. Reason 4, we said was substitution. And then 4 to 5, we went from equals to congruent, so then we're back to definition of congruent once again. Hopefully that was working better for you. The next one, we have, last but not least, I'm going to change colors one more time, go back to blue. We are given 1 and 3 are congruent. We want to prove angle ABD congruent to CBE. So these two are the ones that are congruent, is what we want. That angle and the other angle here. All right. Well, what I would use is I would use what you learned in 2.5 from the other day, where angle 2 ends up being shared between both, so it is reflexive. So it is reflexive, and then 1 and 2 make angle ABD, and 2 and 3 make angle CBE, so then you could use the addition to create that angle. So what does this one look like? We'll start with angle 1 is congruent to angle 3. Underline it, it's given. We know that angle 2 is reflexive, so angle 2 is congruent to angle 2. It needs to have a reason. If you like it from the diagram, go right ahead. So we want to add these two together, right? So these two statements right here, actually you can combine them and you can just create this new idea and say angle ABD is congruent to angle CBE, and you have it in 2 reasons. Reason 1 was the reflexive, and reason 2 was the addition. Do you have to use this idea? No, but that's the best way to do a question like this. So that's what I would use that new idea of reflexive and the addition to be able to do this one. Hopefully this review video helps you understand proofs a little bit more.